Hello guys, my name is Lazaro and today we're going to be doing a LeetCode problem. This problem is called minimum number of days to eat n oranges. There are n oranges in the kitchen and you decide to eat some of these oranges every day as follows. We can either eat one orange, or if the number of remaining oranges n is divisible by 2, then we can eat n divided by 2 oranges. And if the number of remaining oranges n is divisible by 3, then we can eat 2 times n over 3 oranges. So 2/3 of the oranges. And we can only choose one of these actions per day. So we can either eat one orange, or we can eat half of the oranges, or we can eat 2/3 of the oranges. We can only eat half if it's divisible by 2, so if it's even, and we can only eat 2/3 if it's divisible by 3. We are given the number n, which is the integer, so which is represents the amount of oranges in the kitchen that we want to eat. And what we want to return is the minimum number of days to eat all of these n oranges. So for example, if we have here n is equal to 10, the answer would be 4 because on day 1 we can eat one orange to would leave us with 9. Then on the second day, since 9 is divisible by 3, we can eat 2/3. So 9 minus 2 times 9 over 3. 2/3 of 9 will be 6. And then 9 minus 6 will be 3. Then on day 3, we can eat 2 oranges because 3 is divisible by 3. Therefore, 3 minus 2 will leave us with 1. Now we only have one remaining orange. Then on the 4th day, we can eat one orange, and then we will have no remaining oranges. So we need a minimum of 4 days to eat the 10 oranges. Now example 2 follows a pretty similar strategy to example 1, so I'm not going to go over that. So now let's start to the doodling, because this problem is actually much easier than it seems. Even though it's categorized as in hard, it's actually really simple. First, let's agree that we can either eat one orange, else eat half of the oranges if n modulo 2 is equal to 0, or we can eat 2/3 of the oranges if n modulo 3 is equal to 0. So these are the options we can choose for every single day. So let's say our n is equal to the first example, I think it was 10. Yes, 10. So if n is equal to 10, worst case scenario, we will take 10 days, where every single day we only eat one. So let's write out those numbers of days. But now, of course, we don't want to just eat one. At every single day, we want to eat as much as possible, which is this option here, where we eat 0.66 or 2/3 of the oranges remaining. So what I'm going to do is I'm going to color all the all the even days in yellow. So that's 2, 4, 6, 8, then 10. Then I'm also going to do the exact same for all the days that are divisible by 3. So that's 3, 6, and 9. Now realize that the answer was 4 because from 10 we can jump to 8, and then from 8 we can jump to 6, then to 4, then to 1, and then to 1. But this is 5 days. But what we want to do is from 10, let's jump to 9. From 9 we can jump to 6. From 6 we can jump to 3, and then from 3 we can jump to 1. And this is 4, which is the answer. Now, what the importance of this is that for every single day, we want to either move to a day that is divisible by 2 or move to a day that's divisible by 3. We really don't want to do any recursive calls for just -1. We can instead, let's say we're on day 7, correct? Let's say we're on day 7. If we're on day 7, instead of making a recursive call of just 7 minus 1, what we can do is 7 modulo 2 plus that recursive call with n divided by 2 oranges. And we could do the exact same for modulo 3, so 7 modulo 3 plus that recursive call if we were to eat 2/3 of the oranges. And this is all we really want to do. The reason we want these modulos is because instead of calling the 7 minus 1, which will be a waste, we can just compute how many days it would take us to get to the next closest even, or how many days it would take us to get to the next closest day that's divisible by 3. So what we want to minimize is these two calls right here. And of course, we want memoization because we might do repeating work. So we want to take advantage of memoization so we don't have to recompute that unnecessary work. We can just call it from our hash table or array or whatever you set your memoization to. So now we can get to the code and we can actually write this out. Now this is pretty straightforward, and also something I want to point out is that this problem, it actually has a hint, and it's the most straightforward and informative hint I've ever seen. Because if you've done any dynamic programming questions before, you understand how to fully answer this question just by the first hint. So memoization, I'm going to set it to a hash table. Then I'm going to call this function solve, where it takes the remaining oranges. Now if oranges is equal to 0, let's return -1. I'll explain why we're returning -1 shortly. Or now another if we want is if oranges is less than 0, let's return infinity, because we don't want to consider this uh, a negative amount of remaining oranges. We want to eat exactly the amount of oranges. And if oranges is in memo, then let's just return whatever we previously computed. Now let's set answer equal to 1 plus the minimum of oranges modulo 2 plus solve of oranges divided by 2, and then oranges modulo 3 plus solve of oranges divided by 3. Let's also add this to our memoization table, and let's return answer. So like I said, the reason I'm returning -1 is because if we were to call this with exactly if we were to call this function with exactly 0 as the remaining oranges, let's return -1 so we can cancel out this +1. Because we don't want to add another extra day. We know we can stop uh, at whatever call or whatever recursive call called a solve with 0 here as the parameter. No, now from here, all we really have to do is just return solve with n. Now let's run this code, see if I made any mistakes anywhere. I didn't. Now let's submit. And it gets accepted. Perfect. So as you can see, this is actually a pretty simple problem. Even though it's labeled as hard, it is extremely straightforward, mostly thanks to the hint. But the only real trick to it was that we don't need to have this recursive call of just -1. For example, we don't need to do solve of oranges minus 1. This is completely unnecessary. Instead, what we can do is just take the modulo to see how many days are closest to either uh, an amount of oranges that's divisible by 2 or 3. And with that, we can solve the problem if we also take into account memoization. So hopefully this video was able to help you guys. If it did, please leave a like and consider subscribing. But other than that, thank you guys for watching.